I'm Anil Kumar. Here is part 2, review on MCR3U functions. This video is especially for my student Shruti, who wants greater in-depth revision of trigonometric functions. So I've taken a wide variety of questions here. We'll actually have 7 questions in this particular video. You can always pause the video, copy the questions, try them out, right? So the variety includes understanding sinusoidal functions, expressing them in simpler forms, solving equations, trigonometric identities, and word problems, right? So we have 3 word problems here. So this is question number 5. You can always pause and copy the question. And then we have question number 6. On sinusoidal function, you need to model a situation, that is the moon visibility size. And then we have question number 7, which is a 3-dimensional trigonometric application. Copy these questions, try them out, and we'll begin with answering the questions one by one without wasting much time. And I hope it helps you in your final exam. Question number 1. State period, amplitude, equation of sinusoidal axis, range, and phase shift for each of the following. So the first equation is y equals to 5 sine x by 2 minus 15 degrees plus 1. Now, if you get an equation like this, you should rewrite the equation as 5 sine, factor out the coefficient of x, which is half in this case, right? So you get x minus 30 degrees. So the phase shift actually is not 15 but 30. So this is very important to understand. Is it okay? So that is your first function. The second function is y equals to 3 minus half cos 5 pi 6. Let me rewrite this also as minus half cos 5 pi x plus 3. So it becomes simpler since we are used to looking at these equations in this fashion. Perfect. Now I think it's easy to write the characteristics. So let's begin with all these characteristics one by one. We'll try to give what is the period. So we want to write what is period, what is amplitude. You can actually take this time, let me write just axis, range, and phase shift. Correct? So if you look at it, you need to calculate the period. This is the k value, half. So the time period t is actually equals to 360 degrees divided by k, which is half, right? So that gives you 720 degrees. So that is the period. Now similarly on the right side, the time period t will be equals to, now this is given in radians, 5 pi, correct? So in this case, you will divide 2 pi by 5 pi, the k value, and the period will be 2 over 5. Is it okay? I'm not converting them into decimals. However, it's very easy. You could multiply by 2, get 20 and 10. Do you see that? I mean, 4 over 10, which is 0.4. Okay, so that becomes the time period. Amplitude. Amplitude can be straight away read 5 and half, right? Amplitude is always, you should write this as positive, never negative. So don't write minus half. That could be a mistake at times. Always take a positive value. So the amplitude here is 5 units. And on this side, the amplitude is not 3. It is half the coefficient of cosine function. Do you understand? So the amplitude is half here. Axis is this value. So we get axis. It's good to write y equals to 1 as the axis. And in this case, y equals to 3 will be the axis. Range. Now range basically is from the axis how far you go. So you go 5 units up and 5 down. And therefore, we are looking at maximum and minimum. So when we talk about range, we are talking about how far you go from the axis. I hope you get this point. The idea here is if you draw a sine wave or a cosine wave, if this is the axis, in that case, the maximum you can go is 5 up and 5 down. So in this case, as you see, the axis is at 1. So if you do plus 5, you come to 6. And if you do minus 5, you get to minus 4. And therefore, the range here for the value of y, range is always y, correct? So it is between these two values. It is greater than minus 4 in this case and less than 6. Does make sense to you? Do the same operation here. So it is from 3, you have to add this. So you could do 2.5 when you subtract, right? And the y value will be between 3.5, less than 3.5, and greater than 2.5. Is that okay? So we just took this. The last question here is phase shift. Now that is a very critical question. If you do not factor, you are going to get 15, which is a wrong answer. So it is 30 degrees to the right. So it's good to write 30 degrees right. In this case, the cosine function actually, since we have this negative, it starts like this. Do you see that? So if you look at it carefully, the actual cosine wave starts half the period away. This negative actually is a phase shift, right? So we are comparing with cos x when we are writing our phase shift. So if you compare with cos x, which starts half the cycle away, the phase shift should be how much? Half of this, right? So the phase shift is 2 over 10. 2 over 10 or 0.2, right? Do you understand? So this is very important, and at times I've seen students struggling to get the correct phase shift. So I hope that is absolutely clear. Let's move on to question number 2. Express in simpler forms. So we have two equations here. Let me rewrite sine cube x plus sine x cos square x minus cos x tan x, correct? So you could take sine x common in the first two. So we get sine x as common. We get sine square x plus cos square x. And here we'll write tan as ratio of sine and cosine. Perfect. So as you can see, cos x and cos x cancel. And what we get here is sine x. And what is this? We know sine square x plus cos square x is 1. So let me write down. Sine square x plus cos square x equals to 1. So I'm replacing this with 1. So 1 times anything is sine x. Perfect. And here we are left with sine x. So sine x minus sine x is 0. So this could be written as 0. So we have done part A. Now let's do part B. The question here is sine of 90 degrees plus x minus cos of 270 degrees minus x plus sine of 270 degrees minus x. Now this is also a co-function identity. Now let us sketch and try to understand. If I have sine 90 plus x, let us compare with this situation where that is our standard triangle, the angle being x for us. Now when I say 90 plus x, it really means that 90 plus x, the triangle is kind of rotated, right? And you get it here. So the triangle comes in this situation. So that is 90 plus x. Is that okay? So as we know from the rule that all are positive here, sine positive, tan positive and cos positive. So sine is positive in quadrant 2. So you see this remains positive. However, the triangle sides have interchanged, so sine becomes cosine. So this could be written as cos x. Do you understand this? So now what we are also talking about is co-function identity. So some of you might like to review cofunction identity at this stage. It is a very important topic. Now let's look into cos 270 minus x. So I'm going to compare all my triangles with the green triangle here. 270 minus x means we are now here, right, in this position. Here cos is negative, so we get negative, and cos also becomes sine, so we get write this as sine of x. Is that okay? The last one here is sine of 270 minus x. Now if sine of 270 minus x, we are again in the same place. Here sine is also negative, so we can write this as minus, but it is cos since the sides change. Do you understand? So that is the third part. Now we can open the bracket and write down what we have. So we have cos x plus sine x, and that becomes minus cos x, and that indeed is sine x. So the second expression reduces to sine x, the first one to 0. So I hope that is extremely useful to you. Feel free to write your comments and share your views. Question number 3. I'd like you to pause this video, answer this question, and then look into my suggestions. Question number 3. Solve 2 sine squared 2x minus sine 2x equals to 1, where x is between 0 degrees to 360 degrees. I hope this review at the end of your session may be useful as a learning process also. So let me rewrite this question. It is not that clear. So we have 2 sine squared 2x minus sine 2x equals to 1. I'll bring 1 to this side, so I get minus 1 equals to 0. Is it okay? And we want to work in the domain when x is between 0 degrees to 360 degrees. Remember, we have 2x here. So for domain of x, it is between 0 to 360 degrees. For 2x, it should be how much? Multiply by 2. So we get 720 degrees. This is a very, very critical step to understand. So I hope you understand and appreciate it, right? So this is extremely important to understand, right? I'd like you to note this. Now to the left side, the equation which we have is a quadratic equation where we could factor this, right? So we could write this as 2 sine squared 2x, since we need negative here, and 2 times 1 is minus 2. So we get minus 2 sine 2x plus sine 2x minus 1 equals to 0, right? So we have split this term in between as combination of the other two, which can help us to factor. So in the first two terms, we can factor 2 sine x, sine 2x. What we get here is sine 2x minus 1, and here we already have sine 2x minus 1. Now sine 2x minus 1 can be taken as a common factor. We get 2 sine 2x plus 1 as the other factor equals to 0. So that gives us possibility of 2 sets, which is, we can say this equation is true if sine 2x equals to 1, or when sine 2x equals to, we'll take this 1 to the right side and divide by 2, which is minus half. Does make sense to you, right? So just solve this. So from here, we get 2 possible equations, right? So the factors could be 0. That gives solutions for these equations. Now, sine 2x equals to 1. What are the possible values? Whenever you are working with values like 1, 0 or negative 1, I always prefer to sketch the graph. So for sine, you know, the graph is kind of like this. You see, that is the sine function. And as you can see, it is 1 at 90 degrees, correct? So it is 1 at 90 degrees. So that means if you are working in this domain 360, you get 90 degrees. But if you're working in the domain of 720 degrees, that is the sine function, right? 720 degrees, you get another solution, which is 90 plus 360, correct? So that is 360 plus 90. So if you add 90 to this, you get 450, correct? So those are the two solutions. So you can always use your calculator. So you get 90 plus 360, which is 450 degrees. So for 2x, we have two solutions. One is 90 degrees, the other one is 450 degrees. And for x, we are going to divide them by 2. Do you see that? And therefore, the solutions are 45 degrees and 225 degrees. As you can very clearly see, both these solutions for x are within the given domain. Perfect. So to get that solution, we have to actually consider the transformation which we did. I hope that makes sense, right? Now let's look into the second one. Sine 2x equals to minus half. How do we solve this? Now that is in itself a very good question to answer. So what we have here is minus half. That means sine is either in quadrant 3 or in 4, correct? You know, sine is positive here. All are positive here. In these two quadrants, tan and cosine are positive. That means we are looking for an acute angle which is going to give us a value of half, and this acute angle will be related, and then we are going to find two solutions. Got it. Best way to do is to make special triangles so that we can actually give solution as exact values, right? So I hope you remember these special triangles. The whole idea is to review what you have learned, right? So this is our special triangle where the angle here is 60 degrees and that angle is 30 degrees. So you can see for half value of sine x, the angle is 30 degrees. So this alpha, the acute angle, so what we are trying to say here is that this acute angle is 30 degrees, okay? So for negative half, we have two situations, correct? Those are the two situations. So what we get here is that the 2x could be equal to 1 in this triangle, which is 180 plus 30. Let me write down 180 degrees plus 30 degrees. The other one is 360 degrees minus 30 degrees. Now these two angles are within 0 to 360. Since we have 2x, we are going to work in the domain 0 to 720. So add 360 to these. You get it? Add 360 to these, correct? So let me work it out. So if I do 180 plus 30, then 8 plus 3, 11, 210. That gives me 330. Now we are adding 360 to this. That is to say, let's use calculator. So here will be 210 plus 360, which is equals to 570 degrees. And then we have 330 plus 360, which is 690 degrees. Do you see that? So I added one full cycle for each to get the other two answers. Now the question is, what is x? So to find the value of x, we are going to divide them by 2. So we get 210 by 2, 330 by 2, 570 by 2, and 690 degrees, all are degrees by 2, correct? So if you do that, you get additional values of x as 210 divided by 2, use calculator, right? So you might just mess and get a wrong answer at the end. There is no point. Divide by 2, 165. 570 divided by 2 is 285. All are in degrees. And then we have 690 divided by 2, which is 345 degrees. Got it? So that is how you have to provide all the solutions and clearly write down your answer as x equals to 45 degrees, 225 degrees, 105 degrees, 165 degrees, 285 degrees, and 345 degrees. At times, we can also ask this question as how many solutions will it have? In multiple choice questions, right? How many solutions? Number of solutions are 1, 2, 3, 4, 5, 6, right? So the answer for how many solutions is 6. Do you see that? It's very important to understand the concepts which I've shown you while solving this question on trigonometric equations. Take some rest, go to question number 4, and then we'll continue. Question number 4. I hope you are with me. This is based on identities. I've actually taken very simple cases. I'd like you to go through my other videos on identities where we might have few challenge questions for you. The idea of taking up these two questions here is to remind you that at times the identities could be solved very easily, right? So let's see how. Sin x plus cos x divided by sin x minus cos x equals to secant x plus cosecant x divided by secant x minus cosecant x. What you can do is you can begin from the left side, which is sin x plus cos x divided by sin x minus cos x. Now we want to really convert them into secant and cosecant. So secant is 1 over sine, or 1 over cos. Cosecant is 1 over sine. So basically we have to convert them to their reciprocal ratios. How can we do it? So the idea here is what we can do is that we can divide both numerator and denominator by product of sin x and cos x. Do you get the idea? As soon as you do this, let me show you what happens, right? So what we get here is we get sin x divided by sin x cos x plus cos x divided by sin x cos x over sin x divided by sin x cos x minus cos x divided by sin x cos x. What do you notice? Well, we could cancel few terms and then write them as the reciprocal ratios, right? So 1 over cos x, do you see that? So what you get here is 1 over cos x minus 1 over sin x over 1 over cos x. I mean, this is plus, this is minus 1 over sin x, which is indeed equal to what you wanted, right? Which is indeed equals to secant x plus cosecant x over secant x, minus cosecant x. Is that clear? So a simple step, just dividing straight away gives you the right answer. So these steps I introduced so that it helps you to correlate. So I hope that's absolutely clear. So it's very simple, correct? Now, to do this question, what we can do is, we can actually start with left side. Okay, let's begin with the left side, which is, so that is the right side. Is that okay? So we have to write left side equals to right side, and so the identity has been proven. So left side here is cosecant square x minus cosecant x cot x. Let's write them in sine and cosine terms. Cosecant is 1 over sine, this is a square, so we'll write square x minus 1 over sine x, and that is cos x over sine x, correct? So that gives you a common denominator of sine square x. When you multiply, you get sine square x. And what you get here is 1 minus cos x. Now, sine square x is 1 minus cos square x. And in the numerator, we have 1 minus cos x. Now, 1 minus cos square x could be written as 1 plus cos x times 1 minus cos x, right? And we have 1 minus cos x in the numerator, which cancels, right? So this factor cancels, and we are left with 1 over 1 plus cos x, which is right side. Is it okay? So we have shown how left side is equals to right side, and so the identity has been proven. So I hope it's absolutely clear. So you could get very simple questions like this also. You need not waste your time in just doing very, very difficult questions. Try to get the concepts clear. That's my advice. So let's move on and do application questions now.